Hey everyone, welcome to Science for Everyone with Tom Copeland. I'm Tom Copeland. Let's get down to science. So today we are talking about how to find the average atomic mass. So if you look at this periodic table, that top number is the atomic number, and it is telling you how many protons are in an element. But that bottom number is the atomic mass or atomic weight, and it has a decimal. So why is that a decimal? The atomic mass is the number of protons plus the number of neutrons. But the thing is, we have different versions of every element, and those are called isotopes. So every atom or every element has at least one extra version of that atom. And those extra versions have usually extra amounts of neutrons. So that's why that atomic mass is a decimal point. It's an average of the different versions of that element or the different isotopes. Most elements have a stable version, which is non-radioactive, and an unstable version, which is radioactive. There are some examples of elements that have no stable versions, like uranium. So uranium, all versions of uranium are unstable and they're radioactive. But most versions of most elements are not radioactive and they're stable versions. So we are going to learn how to figure out the average atomic mass. So again, if we look at what an isotope is, it's different versions of that atom that have the same amount of protons but different amount of neutrons. So lithium, this bottom number, this is isotopic notation. This bottom number is very important. Lithium always has to have an atomic number of 3 because if lithium does not have 3 protons, it's not lithium. The protons give the identity to that element. Now, these top numbers are the atomic masses. So we have lithium 6. Lithium 6, 6 minus 3, we will have 3 protons and 3 neutrons. Lithium 7, 7 minus 3, we will have 3 protons again, but 4 neutrons. And lithium 8, 8 minus 3, we will have 3 protons, but 5 neutrons. If we look at this other example of oxygen, we have oxygen 16 and oxygen 18. Again, if you notice, both versions have 8 protons. What's different is the number of neutrons. And in most cases, you have extra neutrons, and those extra neutrons make the nucleus unstable and radioactive. So it's very important to understand which isotope we're dealing with. So how do you find the average atomic mass? So what you have to do, you have to know all of the versions of that element, the isotopes, and how common they are found. So what is their occurrence? What is their percentage? So if we look at this example, we have rubidium has 2 common isotopes. We have Rb85 and Rb87. And then again, that 85 and that 87, that's the atomic mass for that isotope of Rb. So here we have the abundance of 85 is 72.2%, and the abundance of Rb87 is 27.8%. And we need to figure out what is the average atomic mass of rubidium. So what you do, you take the atomic masses and you multiply it by the occurrence or the percentage. So here we have 85 times 0.72. Now this is important. You have to take this percentage and put it into a decimal. So if you have a percentage, you have to move the decimal point over 2 spots to the left. So we have 85 times 0.72 for Rb85. For Rb87, we take the atomic mass, 87 times 0.278. Again, we had to move the decimal point over 2 spots. And then we add up our sums and we get 85.386. So this is the average atomic mass of Rb85 averaged with Rb87. And if you notice, 85.386 is a lot closer to RB85 than it is to RB87, which should make sense because 72.2% of the time, you're going to be dealing with RB85. That's just the percentage that RB85 exists. So let's look at one more example. So here we have to calculate the average atomic mass of bromine. So the first isotope has an atomic mass of 79 AMU. That AMU just stands for atomic mass unit. And it is found 50.69% of the time. So that's its occurrence. The second isotope of bromine has a mass of 81 AMU, and it is found 49.31% of the time. So again, we take the 79 AMU, or the atomic mass, times it by 0.5069, and we're moving that decimal point over. And then for the second isotope, we take 81 times 0.4931. We add up those sums, and we get 79.9862. So again, this is the average atomic mass based off of isotopes. This is why when you look at a periodic table, the atomic mass or the atomic weight is going to be in a decimal point. So this has been Science for Everyone with Tom Copeland. I'm Tom Copeland. If you like these videos, subscribe, comment, share, and just remember that science really is for everyone.